Hello everyone, I'm here to give you an example of Dijkstra's algorithm. So basically Dijkstra algorithm is an algorithm that tells us what is the shortest path from a node to another node given a graph, right? So suppose we have a graph which is like this and we want to go from node A to node I. So our question is, what is the shortest path from these two nodes, right? And actually, Dijkstra's algorithm uses the idea of dynamic programming, right? So we need to fill in the table. We need to use new information to update our table, right? So initially we have a table which is like this, right? So let me explain what does this table mean. And if you see that for each entry it has two elements right now, and the first element 0 in this case is the shortest path from node A to node A. So because of starting point is node A, right? So here is the shortest path from node A to node A, so it's 0, right? And the shortest path from node A to node B is infinity, right? Because initially we haven't seen this graph, right? We have no information about this graph, so we do not know how can we get from node A to node B. So the shortest path currently is infinity, and for node C is the same, right? Is infinity, and so on and so forth. And the second here is the predecessor. The predecessor is in this case, we can know that we can get from node A to node A via node A. So the predecessor is like this, and currently we do not know the information about this graph, right? So it is a convention that the initial predecessor of each node is the node itself, right? So we can see that for node B, the predecessor is B, and for node C, the predecessor is C, right? So on and so forth. And now, after knowing what does this table mean, we should keep updating our table, right? So firstly, as our starting point is node A, right? So the first node that we should visit is node A, right? So given node A, what new information do we have? So we know that node A has 3 neighbors, node B, node C, and node D, and we can use this new information to update our table. So let's first look at node B. And for node B, currently we know that the shortest path from node A to node B is infinity, right? So if we know that, hey, we can get from node A to node B, hey, because there is a length, there is an edge, right? And the length of the edge is 3, right? So we can use this new information to update our table. So in this case, we can go from node A to node B via node A. So the predecessor here should be node A, and the shortest path, the length, the shortest distance should be 3, right? So we update our table for node B. And then the next information is here we have an edge from node A to node C, right? And the length is 1. So can we use this new information to update our new table? The answer is yes, because currently we see that the shortest path is infinity, right? So if we know that we can go from A to C and the length is 1, we can use it to update the information for node C, right? So here for node C, we can update it like this, right? And similarly, we can update node D using the new information here, because we have an edge of length 7, right? So we update the data for node D. And after we have traversed all the neighbors of node A, we have used all the information that the node A gives us, right? So after we visiting node A, we marked it as visited, as finished, right? Because we have used out all the information for node A. So we use a check symbol here to mark it as finished, as visited, right? So the next node we want to use, the next node we want to traverse is node C, because for all the among all the unvisited, unfinished nodes, we know that node C had the shortest distance from node A to node to it, right? So we use it as our next node to visit. So here, for node C, let's see what new information we have. We know that node C has two neighbors, node B and node E, right? So let's first look at node B. So node B here, let's see. Currently, we can go from node A to node B where node A and the shortest distance is 3, right? So if we know that, hey, we can go from node A to node B via node C, because C to B is of length 1, right? Can we use it to update our table? We know that we can go from C to B, right? And the length is 1. And we look at C. For node C, we can go from node A to node C of length 1, right? So 1 plus 1 is 2, right? So if we choose this piece, the length of the shortest piece is of the piece is 2, right? And if we do not use this new information, we do not accept the new information to update our table, our previous length is 3, right? So we should use this new information. We should accept this new information, right? So we update the node B here, and we can say that we can go from node A to node C via go from node A to node B via node C, right? So for node B, the predecessor here is node C, and then we have used the information from node C to node B, and another information we should use is here. We want to use the new information from node D to node C to node D. So let's look at node D. For node D, we can see that currently, if we do not use this information, the shortest path from node A to node D is 7, right? So if we use this new information, we can see that we can go from C to D, and for C, we can go from A to C. So if we choose this length, to choose this path, the length is 6, right? So we should accept the new information, and we should update the table using our new information, right? So here we should update it, and the predecessor of node D should be node C, right? So here is the updated